My name is Stephanie Valencia and I will be presenting Co-Designing Socially Assistive Sidekicks for Motion-Based AAC. This work was done with collaborators Michal Luria, Amy Pavel, Jeffrey Bigham, and Henny Admoni from Carnegie Mellon University. Augmented speakers use communication devices as a primary verbal communication method. In the image, an augmented co-designer is sitting on his wheelchair facing his AAC device. He uses a head switch to select words and letters to compose a message he wants to speak. These AAC devices, also known as augmentative and alternative communication devices, enable speech generation but do not currently provide a channel for nonverbal gestures and motion-based communication. Nonverbal gestures support communication in many ways. They can help with turn-taking, regulating conversation dynamics, and helping clarify a speaker's message. All things that are currently challenging in augmentative and alternative communication. Prior work has shown how peripheral robots can use different motion-based behaviors to support conversation. A robotic object resembling a microphone has encouraged participation in a group by orienting and tilting towards the person that has been speaking the least. Similarly, Keep One, a non-anthropomorphic robot tracking the aggressiveness of a conversation, conveyed an emotional response to it and evoked empathy, eliciting behavior change. Both of these examples motivate our work in exploring robots as companions that can influence a conversation and enhance human interaction rather than distract from it or replace it. More specifically, we use the metaphor of robots as sidekicks that has been explored in prior work and define robot sidekicks as those that support a protagonist by existing as a secondary entity and appearing only when needed. We build on this framing to explore the design of peripheral robot sidekicks that increase augmented communicators' agency in conversation through nonverbal behavior. Through a co-design workshop, we explored how socially assistive sidekicks might support AAC interactions. Our co-designers included 2 augmented speakers, 3 of their close conversation partners, and 3 puppeteers. Puppeteers understand nuances of movement and use motion to elicit specific interactions and responses. We leverage their expertise to create specific motions and behaviors for envisioned sidekicks. We split our workshop in 3 phases: telling, making, and enacting. Telling activities focused on scaffolding the sharing of stories of current lived experiences, reflecting on what mattered to augmented speakers in communication. Making consisted of embodying solutions in the form of physical prototypes to define possible psychic forms and aesthetics. Lastly, for the enacting phase, puppeteers explored different psychic motions through behavior improvisations. One important challenge in our work was making sure our co-design workshop was accessible. To make our co-design workshop accessible, we created a shared understanding of co-design, workshop goals, and individual communication preferences. We also allowed enough time for communication by sending workshop prompts and the schedule in advance, as augmented communicators may want to prepare messages beforehand. We also enabled communication post-workshop. The idea is that communication is not rushed and different feedback channels are available. We also made sure that materials were accessible. For example, we checked that we had tables that were easy to access while on a wheelchair. We labeled all visual materials with numbers for ease in referencing, so that augmented speakers could say the number instead of having to type all the words. Now, let's go to our findings. Our findings can be summarized in 4 key aspects of a psychic design space for augmented nonverbal communication. A refined set of augmented communicators' conversational goals that a nonverbal robotic psychic can support. Design parameters to guide the design of future nonverbal communication psychics. A set of physical prototypes that represent potential psychic forms and aesthetics. And a set of motions and behaviors that are suitable for a range of specific goals. For the purpose of this talk, I will focus on presenting our design parameters, followed by some examples on how this design parameters are manifested in the motions and behaviors generated during puppeteer improvisations. The first parameter is attention. Throughout the workshop, it became clear that one of the most important abilities for a sidekick is to help an augmented communicator gain attention from conversation partners, and also direct conversation partners to pay attention to something else, like the AAC device screen, for example. Generated psychic behaviors had a consistent pattern. First, they made motions to call the partner's attention to the augmented communicator, and then they conveyed the augmented communicator's intended message. In the video, a puppeteer is moving her arm to first invite a communication partner to come close. Once she captures their attention, she points to the AAC device screen to convey the intended message, "Come look at my screen." The second design parameter is precision. The psychic's motions should add precision to an augmented speaker's message. Psychic behavior should also be immediately recognizable and interpretable. Precision can be achieved through slight movement variations, imitation, or demonstration. One idea explored how the psychics could use its eyebrows to convey emotions, like making it clear to others that what the augmented communicator was saying had another tone, for example, that maybe they were mad or they were adding humor. In the same way, psychics could help convey the spoken message, "I have to go now," more clearly by having a psychic look at a watch. Timing is our third parameter. Being able to say things in time is a challenge for augmented communicators, given that operating an AC device takes more time than producing verbal speech. The timing of when a psychic behavior is displayed will be crucial in enabling augmented speakers' timely participation. We learned that the timing of a psychic behavior can vary depending on the context. Psychic behaviors could sometimes overlap with an action. For example, by moving to show others the augmented communicator is typing while they are typing. Other times, behaviors could occur at short intervals, for example, to let the group know that an augmented communicator is ready to speak. In the video, a puppeteer raises a psychic to call for attention, and then after a little bit, points it to the puppeteer playing the augmented communicator. Motion can help bring attention, convey precise messages, and enable timely participation. There are design opportunities to enhance augmented communicators' face-to-face conversations by using socially assistive robots as a form of motion-based AAC. Please refer to our paper, Co-Designing Socially Assistive Psychics for Motion-Based AAC, for more information. I would also like to thank our collaborators and participants for making this work possible. Thank you.